So someone asked this question. Someone sent me a text, and here you can read it. And here is page 34 in the notes, which is what the question is about. Question and page 34. So basically, it's, do you need to pick a certain one for the numerator? And the asker mentioned that basically you don't have to pick a certain one. It's just to avoid having weird fractions. And then, do you need to remain consistent in which one's the numerator and which one's the denominator? And the answer for this is no. You don't have to remain consistent. And yes, that's exactly why, just to avoid weird fractions. And so I'm going to demonstrate that with by plugging in numbers. So we have the two experiments with their rates, and we follow this equation where you put the concentrations to the power of x, or whatever letter you want, and then on the other side the rates. And you do have to, if you have experiment 2 on top, you have to have experiment 2 on top over here. And then experiment 1 on the bottom. So if you do the left and right side math, you will end up with simply that, which I think most of us can see that the right side has this implicit 1, and so x is 1. That's easy enough. Now if you were to invert everything, just to show that it still works, so this becomes upside down, this becomes upside down, and you'll end up with 1/2 on both sides, to the power of x on the left. So again, this is really easy in this case, but if it's not, that's supposed to be an x. If it's not such an obvious case, then you will probably want to put the bigger number on top, just because it is easier to see, I think. Even in the second order case, right here the order, it's first order because we got x equals 1. If it were second order with respect to BrO3, maybe that's bromate. If it were second order with respect to this chemical, then you would end up with that. And this would be what, 4.8. And so in the case where you have the bigger number on top, it's pretty easy to see still. 2 to the power of x is 4, so x would be 2 in my imaginary invented numbers case. Let me make a note of that so people notice these are different numbers. I invented them. So in this invented case, you get x equals 2, because 2 to the power of 2 is 4. And it's a little bit less obvious with the fractions, but it is still true. And if you want to be formal about it, you can say log of both sides, or natural log, doesn't matter. Natural log, log base 10, whatever. I think she uses normal log, so I'll do that. So the log of both sides. So I've shown that algebra, these two steps are just extra for anyone who thinks kind of in a more mathy way, or you can just memorize going straight from here to here. If you type this in your calculator, you will indeed get 2. And you can try it. But as far as the algebra, there's a property of logarithms that you can move the exponent outside as a coefficient. So, kind of interesting.